Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 11 from the October 2017 Core Mathematics C34 paper from Edexcel International A-Level, the old specification. And this question relates to P4, and part A of this question is integration by substitution. So we have, we're told, given that h is greater than or equal to 0 and less than 25, use the substitution u equals 5 minus root h to show that the integral of, and here it's got something written in a bit of a weird way for some of you, maybe, dh over 5 minus root h is given by this expression. So to show that it's given by this expression. So what we're going to do here is, first of all, what does this mean? It basically means integrating 1 over 5 minus root h with respect to h. It's the same thing. Just write the dh over there. That's all it means. We have an indefinite integral, and we have to use the substitution u equals 5 minus root h. So here we have like our thing that we have to integrate, which is this, as some function of h. So let's say we got y equals 1 over 5 minus root h. And our objective is to take this y and to integrate it with respect to h. To take this thing and integrate with respect to h. But we have to introduce a substitution of letter u. So in order to do that, what we're going to do is we're going to say, okay, that's the same as doing integrating y with respect to h du. So y times the h du will give me the same as y dh. Okay, and then in the end, in this case, we have to put everything back in terms of h again. But in the beginning, when we do the integral, because we have to integrate with respect to u, everything in here must be written in terms of u. So y is equal to 1 over 5 minus root h, and u is equal to 5 minus root h, so that's just simply 1 over u. So that's a pretty simple one there for that. So we can say that we can write this as 1 over u. Now we've got to look at dh du. So we're told that u is equal to 5 minus root h. And we've got to find dh du. Right now, to find dh du in terms of u, okay, I think the best thing for us to do is to make h the subject of this little formula. Because if I find du dh, for example, dh du will be the reciprocal of that, but it will be in terms of h. I want everything in terms of u. So what I'm going to do is I'm going to add root h to both sides, and at the same time I'm going to subtract u from both sides. And then I'll square both sides, so I'll have h equals 5 minus u squared, and then I'll find dh du. That's probably the easiest way to do it. Chain rule, 2 times 5 minus u, okay, to the power of 1 times minus 1, because we have to multiply by the differential what's inside the bracket. So that gives us dh du is going to be minus 2 times 5 minus u. Okay, so this is going to be times minus 2 times 5 minus u, and that's going to be integrated with respect to u. Okay, so if I expand this inside there, if I can take the 2 out, I can multiply this by minus 1, so it will be basically minus 5 plus u, so u plus u minus 5 over u. So I've basically taken out the 2, left the minus 1 here, and expanded this bracket with the minus 1. Okay, so minus 5 plus u, so u minus 5. Now to integrate something like this, we have to separate into 2 separate fractions. Here it's very easy. I can't use ln directly here because if I differentiate the denominator, I don't get the same form as the numerator, right? If I differentiate u, I'm going to get constant. Here we have a u term. Both of the same order, so it won't work. But what I can do is I can say this is like u over u minus 5 over u, which gives you 1 minus 5 over u. And that I can integrate. Okay, with respect to u, pretty simple to integrate that. So that will give me 2 times. Now I can get rid of the integral sign because I'm going to integrate. If I integrate 1, I get u. If I integrate 5 over u, it's going to be 5 times ln of the modulus of u. So minus 5 times the ln of the modulus of u. Okay, Remember that this is like 1 over x becomes ln x when you integrate it. All right, now, we can't leave an answer like this because the answer has to be expressed in this form here. Okay, so we have to put the h back in here. So we're going to use our substitution, u equals 5 minus root h. So wherever I see u, I'm going to replace it with 5 minus root h. So I'm going to have here 2, so let's just expand it, 2u minus 5 minus 10. I have minus 10 ln of the modulus of u and plus c. Okay, plus c. Don't forget the plus c. All right, so you're going to have 2 times, as I said, 5 minus root h minus 10 times the ln of 5 minus root h. Now, there's something important that was written up here. Okay, that h is between 0 and 25. So we can say, we know that h is greater than or equal to 0 and less than 25. Therefore, 5 minus the root of h will always be greater than 0, always be positive. Why? Because if I can put 0 in here, the lowest number, I'm going to get 5, which is positive. The highest I can go here is just below 25. If I could put 25 in here, I'll have 5 minus 5, which is equal to 0. But what I can put here is less than 25, so this will always be less than 5. So therefore, you have 5 minus something less than 5, which will always be positive. Okay, and also it will never be negative because h is greater than or equal to 0. So it's always going to be something which is going to be positive. All right. So therefore, the input of this will always be positive. It will never be negative. So that's why I don't need to write the modulus sign anymore. Okay. Okay. So that's important for us to understand. That's why here there's no modulus sign. It is a bracket sign, bracket here, and that's why they gave us this information. All right. Now we're going to expand this. It's going to give me 10 minus 2 root u minus, sorry. What am I doing? I'm supposed to say root h. Okay. So 10 minus 2 root h minus 10 times the ln of 5 minus root h, okay, plus c. Now, you'll notice over here, we have the same thing, except it says plus k and there's no 10. There's no that constant 10. Over here, we got a constant 10 minus. Here we got minus 10 ln 5 minus root h. We've got exactly that. So I'll write it down in the form that they gave us. We've got that. That's already there. Minus 10 ln of 5 minus root h is already there. All right. And we also have minus 2 root h is already there. So minus 2 root h is already there. Oops. Minus 2 root h is already there. Okay, but what we have here, we have this plus 10 and plus c. That's what we have here. And if you notice here, they don't have the plus 10 and the plus c, because what have they done? They have just stuffed it all together in that one constant there. So we can say, let k equals 10 plus c. So therefore, that's where they get that from. It's just it's a constant of integration, which they've just called k, and included the constant from there. Including the constant from there. And so there we have the answer as we are supposed to have it in the same format. Right, so that concludes part A of this question. And now for part B, it says a team of scientists is studying a species of tree. The rate of change in height of a tree of this species is modeled by the differential equation dh dt equals t to the power of 0.2 times 5 minus root h over 5, where h is the height of the tree in meters and t is the time in years after the tree is planted. One of these trees is 2 meters high when it is planted. So when it is planted is when time is 0, because T is the time in years after the tree is planted. So when it was planted, when time equals 0, its height was already 2 meters high. So use integration to calculate the time it would take for this tree to reach a height of 15 meters, giving you an answer to 1 decimal place. So they are asking us to solve this differential equation, dh dt. I'm leaving this gap for a reason, as you'll see later. T to the power of 0.2 times 5 minus the square root of h over 5. Okay, so now, when we solve a differential equation, it's something that we've done since P1. Many students don't realize that. Okay, it just means get rid of the rate, get rid of the dh dt, get rid of the dy dx. So for example, if you have dy dx is equal to 2x to the power of 4, and you want to find what y is in terms of x, yeah, you want to get rid of the dy dx. What we normally write is, okay, we want to find y, so we have to integrate. So you have 2x to the power of 4, integrate with respect to x, which will then give us 2x to the power of 5 over 5 plus c. Okay, that's how we went straight from here to here. But there's something going on in the background, okay, which we don't bother telling you about in the previous kind of units. But there's something going on in the background which will help you understand what's going to go on here. And I'd like you to understand what you're doing, not just be parrots and robots, right? So what actually we're doing, what you actually have to do is to get rid of a rate. I want to get rid of the dy dx. I have to integrate with respect to x. So dy dx dx, the integral of y, the integral of dy dx dx, that will get rid of this rate. That will get rid of the dx. And you're left with the integral of y, which is basically the integral of 1 with respect to y. And if what I do to one side, I must do to the other. So if I integrated this side with respect to x, I must also integrate this side with respect to x. So you're left with the integral of 1 with respect to y. What's the integral of 1 with respect to y? It's y. So that's where you get the y from. And then is equal to the integral of this, and you integrate that with respect to x. So that's where, that's actually what integration actually is. This part of it, we leave it out. We don't bother explaining that until you needed to understand it, which isn't now. When we are solving differential equations, you can get by without understanding that. But I want you to understand what's going on. Not just memorize, just move this there and move that there and just do it without understanding what's going on. All right. So we're integrating this side with respect to t. And we're integrating this side with respect to t. Because what you do to one side, you do to the other. Here you can say the dt's cancel out. Okay, so I'm left with something like this. Now, on this side, I have to end up with anything that has h, because I have to integrate with respect to h. On this side, because it's got dt, I'm integrating with respect to t. Everything on this side has to be with t. So basically here, this 5 minus root h doesn't belong on this side. This is fine. This doesn't belong on this side. So it's like I have to divide both sides by this. So I end up with 1 over 5 minus the square root of h integrated with respect to h equals the integral. I can put the 1 over 5 outside if I want to, of t to the power of 0.2 with respect to t. I could also write the 5 out here if I want to. I'll just leave it there, no problem. Now, in this question, we are given some information that we want to find. So we want to find the time it would take for the tree to reach a height of 15 meters, giving you answer to 1 decimal place. So we want to find the time. So I'm going to put t. Okay, let's say t equals capital T when h equals 15. So let's call this capital T. And at the time when the height is 15, that's the time we have to find t. We know initially when it was planted, when time was 0, the height of the tree was 2 meters. Okay, for this tree, right? Same tree. Okay, so if I solve this differential equation now with these limits, I will get my answer. Now, the hard work has already been done in part A for the integration of this. We integrated it by substitution. And we ended up with this answer over here. Okay, and I'll take this answer. I'll just take it from down here. I'll just put it down here so we can see it. Okay, so that's the answer that we ended up with. Now what I need from this answer is everything apart from the plus k, because the plus k part is going to just become 0, okay, when you have definite integral. When you put 15 in there, then you put 2 in there, the k part will stay as k. It's just going to be k minus k becomes 0. So I'm only interested in this part. I'll write the k in first, because this was actually, I'm answering this question for a particular student, and that was their doubt. What happens to the k? What do we do with the k? I will leave the k in there, and you'll see what happens. All right. So I'm going to initially I'm going to leave it in there, but hopefully you'll understand why. Eventually you'll understand why. Really, what I would do is I wouldn't even write it down. Okay, I'll just put it there for now, just to explain what happens, just to show you what happens. But really, no need to write that k down. Okay, there's no need to write that k down because it's going to cancel out anyway. So this is 15 and this is 2. So this is the integral of that which you already found from the last part A. So if you're wondering how I got this, go back to part A and watch how we use substitution, which they told us to find that this is the integral of that. Now for this, I like to write t to the power of 0.2 as 1/5. So I'll write that as t to the power of 1/5. I prefer to deal with fractions. So that's t to the power of 1/5. So you have 1/5 times the integral of, now I add 1 to the power. So it's 1/5 plus 5, that's 6/5, divided by 6/5, which is multiplying by 5/6. And this has got limits of t and 0. So now I'm going to put 15 into here. So I have minus 10 times ln of 5 minus root 15 minus 2 times root 15 plus k. I'll leave the plus k here for now. And then I'm going to put 2 into here. So I'll have minus 10 ln of 5 minus root 2 minus 2 times root 2. And again, I'll put the plus k. And that's equal to, that cancels with this. So I'll say 1/6 times t to the power of 6/5 minus 0. So I don't need to put the bracket there. So you can see the 5 cancel out. So you're left with 1/6 t to the power of 6/5. Okay, now what do you notice here? This will be k minus k. The k's will cancel out. No need even to have it there. So now let's say we're going to say 1/6 t to the power of 6/5 is equal to. I'll write it the other way around because I want my answer to be t. So I'm just going to write it, just write it the other way around. So I've got minus 10 times the ln of 5 minus root 15. Okay, minus 2 root 15. Plus k minus k there will cancel out. I'm going to have minus is plus 10 ln 5 minus root 2. Not root 15, root 2 now. And minus plus 2 root 2. Okay, so what I'm going to do is I'm just going to stick this all in my calculator. So I'll just do this. I'll say t equals 6 times all of this times ln 5 minus root 15 minus 2 root 15 plus 10 times ln of 5 minus root 2 plus 2 root 2. Okay, all of that. Yeah, that didn't need a bracket there. I don't know why I put it there. But here I do need it because it's this big bracket here. And I'm to find t, if I have t to the power of 6/5, I want to make it t, I'm going to raise it to the power of 5/6. So all of this, the whole of this side, I'm going to raise it to the power of 5/6. And that will give me my value of t. So I'm going to put all of this in my calculator. And let's see what we get. Okay. So I'm going to have bracket 6 times another bracket, minus 10 times the ln of 5 minus the square root of 15. Close that bracket. Spacing, close the bracket. That's that part done. Minus 2 times the square root of 15. Okay, plus 10 times the ln of 5 minus the square root of 2. Close that bracket, plus 2 root 2. Close the bracket, close the bracket. Okay, and raise to the power of 5 over 6. Now let's hope it doesn't say math error. No, it doesn't. Good. So t equals 21.6021. 21.6021. And they want us to give the answer to 1 decimal place. So we can say, it says find the time it will take. Okay, so therefore it will take 21 years. 21.6 years. Did I say seconds a minute ago? No, it won't be seconds. Okay, so it would take 21.6 years to reach a height of 15 meters. Okay, so there's the answer to part B of this question. Okay, and now for part C. Hence, calculate the rate of change in height of this tree when its height is 15 meters. Write your answer in centimeters to the nearest centimeter.